All right, so just like we did last time, we need to simplify these expressions, and we look for like radicals. What do like radicals have to have? Same index and the same radicand. These guys all have the same index because they're all square roots, but they don't have the same radicand. So how do I take care of that? What did I do last time?
Factor tree.
Factor everything, break things down, look for those perfect squares that are factors. Now, a trick here, not really a trick, but just logic and being efficient, is to start with the smallest radicand you have, because that should be the easiest guy to break down. So let's start with the 12. How does this guy break down?
3 and 4. 3 and 4.
Is that the only way to break down 12?
No.
No, but it's the only way that's useful to me right now. And why did I want to do 3 and 4?
Because 4 is a perfect square.
4 is a perfect square. When I take the square root of 4, I get
2.
I get 2. So that 2 comes out front, but what is it going to do with the 5 that's already here?
Multiply.
It's going to multiply. Oh, you guys are on top of things today. So that's 10. And then the 3 stays inside the square root, right? If you ever get those numbers flipped around and you think the 3 comes outside and the 2 stays inside, you will never be right, and you don't understand how square roots work, or any of the radicals for that matter. The square root of 4 is 2. That's why he's on the outside. This is multiplication. Everything inside is multiplication. So whatever comes out with that will be multiplied. So that's why I get the 10 and the square root of 3. Well, notice I've got a 3 left inside this radical. If I'm going to combine this with other radicals, what must also be left inside those radicals?
3.
3. Now does 3 go into 75?
25 times.
Goes in 25 times. Oh, that's nice. And why is that nice? Because 25 is a perfect square. Do I need to break that down and say that 25 is 5 times 5? No. I know that he's a perfect square, and he gives me what? He gives me a 5, so what does that middle term become now?
40.
Minus 40. Bless you, and the square root of 3. Do you agree?
Okay.
Man, sure I'm hoping that 27 has a 3 in it.
Me too.
9 and 3.
I can write this as 3 times 9, and that's super awesome. Okay, or 9 times 3. Give me the look like.
Actually, no, I was going to ask you, because that 3 and that 3 is the same, you don't have to, like, cancel.
3 and the 3.
Well, after you break that 9.
Well, hold on though. This 3 comes on the outside though.
Okay.
So I'm using a different color. This guy comes on the outside as a 3, but there's still a 3 left over. Because how many factors of 3 make up 27? How many times do you see 3 there?
9.
No. How many factors of 3 do you see?
2.
27
No.
breaks
Yeah.
down as 3 times 3 times 3. Now the square root says you take a pair of these guys to get 1 on the outside.
We have 1 left.
But then I've got a 3 left over. He's saying, well, I wish I had a pair. Yeah, why don't you try to grow a pair? But he's got nothing, right? So he stays inside. Sure, I'm glad that was recorded.
Me too. What?
So we have 6. We have a 3 left inside the square root.
Throwing you off your game there.
Now let's come.
Oh my God, guys, he's laughing on camera.
So when I combine all these, what do I have?
Negative 36.
Negative 36 square roots of 3. What do you guys think?
Is that it?
What else could you do with that?
I don't know.
There you go. You can't combine these guys any further. I mean, 36 and the 3, 3 is inside the square root, so there's an operator being done on him, which is that of the square root. There's a function there. 36 would be multiplied times that. So the only other thing that you could do here would be to type this into a calculator and get some kind of decimal approximation. But we don't want to go there because not only is this simplified, but this is an exact answer. When you type this into a calculator, is it exact anymore?
No.
No, it's an approximation. Because any non-perfect radical, the decimal representation doesn't have a pattern and it never ends. Like if I were to say 1/3, what's 1/3? 0.33, the 3's repeat, right? I don't get anything like that with the square root of 3. Let's try another example. Make sure you're ready for this. Give yourself plenty of room. We have 7 square roots of 200 minus 5 cube roots of 16 plus 8 cube roots of 432 minus 13 square roots of 72 plus 21 square roots of 722.
So we get 5 points added on to our semester bonus if one of us just cranks this out right now.
We're going to work through this problem together.
Thank you.
You're welcome. Now, you may see a problem like this on your next test. By the way, when is your next test?
Never.
April.
It's Monday, April 29th. Of course, if you're watching this after April 29th, that date is no longer valid.
A disclaimer.
It's so good to know.
So I've got 4 different radicals I need to break down. Now, what was the trick, or what was the
Like
hint that I
term.
said for the last one? What was the first thing you should try to look at? The smallest number, which one is that? The 16. Now, understand the 16 is inside of a cube root, so I need to find a factor of 16 that is a perfect cube. What sounds good?
2.
2 is not a perfect cube. 4 is not a perfect
2
cube.
and 8.
But if I write this as 2 times 8, isn't 8 a perfect cube?
Oh,
You-
I'm sorry. That's why I said 4.
You know it is, because it's right here on my list of cubes.
Sorry.
No problem.
You know
So-
what I meant.
Now when you post this video, just write that down.
Yeah, make your list of... Press pause, write them down, you got your power sheet. The cube root of 8 is 2. So what's going to happen with the negative 5 that's already out there?
Multiply by 2.
So it's going to be negative 10 cube roots of what? 2. Now I had a 2 left inside this cube root. I have another cube root, and I sure hope that 2 goes into this guy, right? And if it does, that means I'm going to have, hopefully, like radicals. 432 is even, so I know 2 goes into that. How many times? It should be 216. Don't make your math life difficult. Half of 400 is 200. Half of 32 is 16. So half of 432 is 216. Is 216 a perfect cube?
Possibly.
Let me go to
Go
my-
back
Yes.
and rewind to that particular spot in the video and
It's
look at the
6
powers.
cubed.
This is 6 to the 3rd power, so this guy gives me a 6.
6
So-
times 8 is 48.
True that. 6 times 8 is 48. And I still have cube roots of 2, right? Do not drop your index, or I'm going to drop points.
Like it's hot.
Yes, I'm going to drop them like they're hot.
I like when you said that.
If I say things like that, then this generation will stop saying things like that. And they will stop having the next word after the pronoun they be was.
They was.
They was. They was. Really?
They were.
What was they doing?
I don't think I hear many people talking like that.
That's right. People can't English very well. Now, I'm going to look at 200. You may say, but 72 is the smallest number left. It is, but I look at 200 and I think about my bills, right? It's all about the Benjamins, right? It's all about the Benjamins, Javi. So, how many Benjamins do I have?
2.
I got 2 Benjamins. Oh, snap. Isn't 100 nice? Because 100 is a perfect square, and we're inside of a square root. I'm going to put a little square around you because you're so cute. And what's the square root of 100?
10.
Man, you know it's 10. There he is. I don't know the movie you're talking about, but it sounds like a movie I'm not going to watch. Did you say I sound like the white guy?
Yeah, who's white?
Yes, I sound like the white guy.
No.
No kidding. Now, what am I going to do with the 7 that's outside the radical? That's going to be 70. That's the square root of 2. And this is being recorded. That's awesome. Now, 72, I'm hoping that he's just like this other square root and he has a 2 left inside. Does he? 2 times what gives you 72? 36. And then what's the square root of 36?
6 times 13.
Is what? No, really. 6 times 13. What's 6 times 10? What's 6 times 3? Add them together. Yes, 78. You guys really are trying to destroy me. It won't work. Now what about 722?
Oh,
Tell me that 2 goes in. Oh, you forgot that one?
no.
That's all right.
No.
He still loves you too.
No.
How many times does 2 go into 722? 361 times. Wait a minute. I need to pull up my power sheet. Do I get anything useful here?
Yep, 19.
19 squared is 361, so that means... Whoops. I put a box. Why did I put a circle? Goodness.
How dare you, sir?
Yeah, how dare you. So what's 19 times 21? Don't you even dare go to the calculator. Stop it. Stop it. She's doing... I'm glad you guys can't see this.
399.
She gives me the awe-inspiring number of 399. What's left inside?
2.
Now let's combine like terms. I've got minus 10 and plus 48 cube roots of 2, so how much is all of that?
First of all,
It's 38 cube roots of 2. Don't drop your index, right? Then you look at your square roots. Oh, the rest of these guys are all square roots of 2, right?
why'd you do those first?
I just wanted to. They're right next to each other. They just told me that they wanted to be done first. So I was like, okay.
Did he speak to you?
Yeah, I'm the math whisperer. 70 square roots of 2 minus 78 square roots of 2 is what?
Negative 8.
Negative 8.
Square roots of 2.
Then plus 399. What's 399 and a negative 8? So that's 391 square roots of 2. Can I combine these guys at all?
Awesome.
Nope.
Nope.
Why not?
Because they're not like terms.
But they have the same radicand.
No, because it has that.
They don't have the same
Index.
index.
I'm sorry, the index, I said the thing. the
Yes,
key
you're
thing.
very precise with those nondescript words. Now, let me show you something neat about 21 times 19. Do you all agree that 21 is 20 plus 1?
Yes.
And that 19 is 20 minus 1?
Maybe.
And isn't that the difference of squares? Wouldn't that be 20 squared minus 1 squared?
You are a math.
Well, hold on. Check this out. You know what 20 squared is because it ends in 0. It's a nice number. That's just 400 minus 1, and you get 399.
Mind blown.
I know.
Yes.
Craig,
That-
that's not fair, because you're like
Let me
really
go
good.
take-
Yeah,
at
that's not
math.
fair that I'm pulling up things that you had in the last class, the difference of squares. I'm going to write this here for all of you, and for those of you that are watching at home. And
Please go like, it's like this.
this is the difference of squares formula, right? Know it, learn it, love it.